Welcome to lesson 3 on logs. This is going to be our third and final lesson on logs. And in this lesson, I'm going to be showing you how to use logs to solve equations such as this. Let's begin. When we have a variable in the exponent position, we need to use logs. First, I'm going to take the log of the left side of the equal sign and also the right side. And the reason for doing that is because using one of the laws that we've learned, we're able to take that exponent, put it out in the front of the log, giving us x plus 2 times log of 3 equals log of 7. Then, since we're trying to solve for x, we need to isolate the x. And first thing we want to do is get rid of that log of 3 by dividing it on the left and the right side, where we get x plus 2 equals log of 7 over log of 3. And finally, to make the x by itself, all we need to do is subtract the 2, where we get x equals log of 7 over log of 3 minus 2. And then, in order to solve this or put it in decimal format, we need to go ahead and put it in the calculator. And when you do, you'll get x equals negative 0.228756 rounded off to the 6 decimal places. Here's another familiar looking equation where we have the variable in the exponent position. Only thing is we have e as the base, and also we have e to the 2x and e to the x. So first thing we want to do is rewrite this equation so that we have e to the 2x parentheses squared minus e to the x. That way we have it in the quadratic equation format. Then we need to go ahead and factor this. And when we factor this, we're going to start by drawing two sets of parentheses. And we want to ask ourselves, what two things times will give us e to the 2x? And it's going to be pretty straightforward, e to the x and e to the x. And if the constant or the third term is negative, it's going to be always plus minus. And then the two numbers that we're looking for here are going to be multiply to 6, which will be 1 times 6 or 2 times 3. And of course, it could be other way around, 6 times 1 or 3 times 2. And at the same time, we want the difference to be a 1 or negative 1. So I'm going to put the 3 up here and 2 here, giving us the factor form of that equation. To solve, we now have e to the x equals negative 2 from here. And we have e to the x equals positive 3. Remember, when you take anything to an exponent, it cannot be a negative value. So we can eliminate this portion as part of our solution and finish with this equation here. To solve for x, we could take the natural log of left and the right side, because natural log and the e will cancel each other out, where we take the x and put it out in the front. So we get x equals, again, natural log and the e cancels each other out. And then if you take the natural log of 3 on the calculator, we get 1.0986, again, rounded off to 4 decimal places. This time, instead of an exponential equation, we have a logarithmic equation. To solve for x, we need to get rid of that 4 and also the 3 so that we could have the log by itself. So step 1, subtract 4 from the left and the right side, giving us 3 log 2x equals 12. Next, to get rid of that 3, of course, we're going to divide it by 3 on the left and 3 on the right, where we're left with log of 2x equals 4. When there's no base written, it's given that the base is 10. To change this log equation into an exponential equation, we start with the base, the 10, and bring the 4, the exponent, and then set that equal to the argument, or the 2x. 10 to the 4th power if you do it on a calculator, or by adding 4 0 to a 1, we simply get 10,000. And then we're going to set that equal 2x. And then to solve for x, we just need to go ahead and divide it by 2, where we get x equals 5,000 as our final answer. Here's another example. When we're given log of x plus 2 plus log of x minus 1 equals 1, we need to combine these two logs, make it into a 1 log before we can solve for x. The rule is this. If you have log of a plus log of b, it's equal to log of a times b. So here, that's what we're going to do. We're going to change this into log of x plus 2 times x minus 1. Once again, we're going to change this into an exponential equation where the base will be 10, because since there's nothing written there, we're going to take the 1, put it in the exponent position, and then set it equal to x plus 2 times x minus 1 Continuing with the simplification, we multiply this out. We get x squared plus x minus 2. Take the 10, subtract left and the right, giving us 0 equals x squared plus x minus 12. Factor this. We get x plus 4, x minus 3, where we get x equals negative 4 or positive 3. However, notice that if we take that negative 4, plug it into the original equation right here, then we end up getting log of negative 4 plus 2 or log of negative 2. So remember, when you do logs, you cannot take the log of a negative number or a 0. So if we have log of negative 2 by plugging in negative 4, we need to go ahead and eliminate negative 4 as part of our solution. If you take that 3, plug it into the x here or the x here, it gives a positive value of a log. Therefore, 3 is going to be our only solution. This time we have an exponential equation where the base is e, and whenever the base is e, you do not want to take the log. Rather, you want to take the natural log of left and the right side of the equal sign. And again, natural log in the e cancels out, or natural log of e equals 1, meaning we only have the exponent by itself on the left side. So we have 2x plus 1 equals natural log of 200. Continuing to solve for x, we're going to subtract by 1, so we get 2x equals natural log of 200 minus 1, where we divide by 2 on the left and the right. Once again, we get x equals natural log of 200 minus 1 all over 2. Next, if you put that in the calculator, then it'll come out to 2.1492. Once again, rounded off to 4 decimal places. Here's another example. This time, we have the exponent as a variable on the left and the right side. Here, we could either take the log or the natural log, but I prefer to take the natural log. And the reason for that is it's 2 letters versus 3 letters for the log. So if I take the natural log of left and the right side, we're able to take that exponent, put it out in the front, and put it out in the front, where we get 3x plus 1 times natural log of 2 equals x minus 2 times natural log of 3. Notice the parentheses for both the 3x plus 1 and the x minus 2. Next, we need to go ahead and distribute the natural log of 2 in here and also the natural log of 3 in here. So where we get 3x natural log of 2 plus natural log of 2 equals x natural log of 3 minus 2 natural log of 3. We want to go ahead and isolate or bring everything with x to the left side and bring everything without x to the right side of the equal sign. Where we get 3x natural log of 2 minus x natural log of 3 equals negative natural log of 3 minus 2 natural log of 3. Oh, by the way, that's a natural log of 2 from the 2 right there. Now we're able to go ahead and take the x out to the front, or factor the x out to the front, where we get 3 natural log of 2 minus natural log of 3 equals, again, negative natural log of 2 minus 2 natural log of 3. Our final step is going to be dividing both the left and the right side of the equal sign by this, or 3 natural log of 2 minus natural log of 3, giving us our final answer of x equals negative natural log of 2 minus 2 natural log of 3 all over 3 natural log of 2 minus natural log of 3. So that is going to be our final answer. However, if you wanted a decimal answer, you could plug this, everything that's on the right side, in the calculator, which will give you approximately negative 2.9469, rounded up to 4 decimal places. This equation is similar to the second one I did. However, the difference is that we now have a 4x as the exponent instead of 2x. So I'm going to be using a substitution method for this particular question. I'm going to let the e to the 2x be a, which will make this equation a squared plus 4a minus 21 equals 0, which is much more manageable when it comes to factoring. So if we factor this, we get a plus 7 times a minus 3 equals 0. Solving for x, we get a equals negative 7 or a equals 3. However, we're not finished. We're not solving for a. Remember, we're solving for x. So I'm going to go ahead and plug e to the 2x back in for a. So we get e to the 2x power equals negative 7. And also here, e to the 2x power equals 3. As I said before, anything to an x power or to an exponent cannot be a negative value, meaning the negative 7 or e to the negative 7 cannot be part of our solution. So we're going to leave that out and focus on e to the 2x equals 3. To get rid of that e, we need to go ahead and take the natural log of left and the right side, leaving us with just the 2x, where the natural log and the e cancels out, or become a 1, equals natural log of 3, where x equals natural log of 3 all over 2, or if you put that in the calculator, you get 0.5493, rounded off to the 4 decimal places. In this example, notice that we have log of base 2 in 4 different places. So first thing I want to do is combine the 2 logs on the left side, which will give us log of, again, base 2, 3x. Remember, we multiply the arguments. Next, we're going to combine these 2 logs as well into 1, where we have log of base 2, 5 times x minus 2. Again, we multiply the 5 and the x minus 2. And one of the rules is that whenever you have a log of the same base on the left and the right side, we're able to cancel them out or compare just the arguments, where we have 3x equals 5 times x minus 2. And if we simplify that, we get 3x equals 5x minus 10. And then to solve for x, we go ahead and subtract 3x from the left and the right side, giving us 2x equals positive 10, where our final answer is going to be x equals 5. This time we have 2 logs with the same base of 5. However, we're subtracting instead of adding this time. The rule is this: when you have log of a minus log of b, that's the same thing as log of a over b. So using the rule, I'm going to be rewriting this as log of base 5, and then x plus 1 in the numerator, and the x minus 1 in the denominator. Set it equal to. Next, I'm going to be changing this logarithmic equation into an exponential equation by starting with the 5 as the base, and then the 2 from the exponent, and set that equal the argument, or the x plus 1 over x minus 1. And then we have 25. And at the same time, I'm going to multiply by x minus 1 on the right and x minus 1 on the left. So we have 25 times x minus 1 equal x plus 1. If I go ahead and distribute the 25, I get 25x minus 25 equals x plus 1. Subtract the x, which gives us 24x equals, if we add the 25, then we get 26, where x equals 26 over 24, or reduced will be 13 over 12. As the last question of the lesson, I'd like to do a word problem. It's regarding skydiving. The question reads, the velocity of a skydiver t seconds after jumping is given by v of t equals 80 times 1 minus e to the negative 0.2 t power. Then, after how many seconds is the velocity? 70 feet per second. So we're going to replace the v of t with 70, giving us an equation of 70 equals 80 times 1 minus e to the negative 0.2 t power. The first step, obviously, we're going to be dividing it by 80 on the left and the right side, where 70 over 80, of course, is reduced to just 7 over 8. So we have 7 over 8 equals 1 minus e to the negative 0.2 t power. Then if we subtract 1 from the left and the right side, we get negative 1 over 8 equals negative e to the negative 0.2 t power. A lot of negatives here, huh? If we have a negative on the left and the right side, we can multiply by negative 1, making it positive for the left and the right side. And finally, to get rid of that e, we want to go ahead and take the natural log of the equation on the left and the right side, where natural log of e is canceled out or turns into 1, where we have natural log of 1 over 8 equals negative 0.2 t by itself on the right side. Then finally, to solve for t, all we have to do is go ahead and divide it by negative 0.2 on the left and the right side, where it gives us an answer of t equals 10.4 seconds, rounded off to 1 decimal place. So there you have it, folks. I hope you enjoyed this lesson on logs and a lot of the examples that I've worked out. And hopefully this will give you a better understanding of how to solve logs and why logs is so important in math. As always, thank you for watching. And if you haven't already, subscribe. Don't forget to hit that like button.